In this problem, a block of mass 5 kilograms compresses a spring by about 6 centimeters, which is also equal to 0.06 meters. The spring also has a spring constant K of 300 newtons per meter. The problem wants us to discover the block's velocity after it is released. And in order to do this, we need to understand the two types of energy that are involved in this problem. The first and initial type of energy is elastic potential energy, and this is the only type of energy as the block remains stationary when it compresses the spring. As the block is released, more and more of the elastic potential energy is converted into kinetic energy, until eventually, when the block leaves the spring, all of the elastic potential energy has been converted into kinetic energy. This is because kinetic energy is related to velocity, while elastic potential energy is related to how far the spring is compressed. This means that as the spring becomes less and less compressed, its velocity increases more and more. To illustrate this, when you write out the equations, 1/2 spring constant K times the distance the spring is compressed in meters squared is converted into 1/2 times the mass of the block times the velocity that the block is moving squared. Now, in order to solve for the block's velocity, since elastic potential energy is the only type of energy initially, and the kinetic energy is the only type of energy in the final aspect, and because of conservation of energy, we can say that both this initial value and this final value are equal to the total energy. Again, because of conservation of energy, and since initially elastic potential energy is the only type of energy, and kinetic energy is in the final aspect the only type of energy, then the total energy at any point must add up to equal either the initial elastic potential energy or the final kinetic energy. This means that algebraically we can write elastic potential energy initial is equal to the kinetic energy final, which is also 1/2 k x squared is equal to 1/2 m v squared. Now we need to algebraically solve for v squared. So we could start by removing 1/2 from both sides since it is on both sides. Next, by dividing by m, we get kx squared over m is equal to v squared. But we need to get rid of the squared, so we could say that the square root of kx squared over m is equal to the velocity. When we substitute in the numbers, we get the square root of 300 newtons per meter times 0.06 meters squared divided by 5 kilograms is equal to 0.46 meters per second. And this is our answer.